Hello everyone, today we're talking about inverse trigonometric functions, the last section of chapter 7 that we're going to cover. So they want us to find the exact value of each of these expressions. This tangent raised to the -1 means it wants the inverse tangent. So basically what the inverse function of trig functions does is it's telling us what angle gives me radical 3 for tangent. So if you don't know the angle right off the top of your head, we know that tangent is sine over cosine. Okay, and the values that will simplify to radical 3 is radical 3 over 2 divided by 1/2. And that gives me a radical 3 if you flip and multiply. And the angle, that gives me radical 3 over 2 for sine. And 1/2 for cosine is pi over 3. So the inverse tangent of radical 3 is pi over 3. Because if I did tangent of pi over 3, I would get radical 3 back in return. Okay, so basically when they want an inverse trig function, they want the angle that gives you that value. So here we have tangent, we want the inverse tangent of negative radical 3. So a negative radical 3 is in the fourth quadrant, or in the, they have in the fourth quadrant. So our negative angle would be negative pi over 6 there. Sorry, that should be negative pi over 3, or 5 pi over 3. So you see that either of these values, either of these angles will get me back to a negative radical 3. So I can say negative pi over 3 will give me a negative radical 3. Also, you could have values in the second quadrant. Right, so you could have 2 pi over 3, that would work too. Right, 2 pi over 3, tangent's going to be negative in the second quadrant. Or you could have a negative 4 pi over 3. All of those values, if you do inverse tangent, will give you negative radical 3. So there's more than one answer there. But since our angles are always going to be less than 90 degrees, right? So your calculator doesn't know how to tell you more than 90 degrees. So your calculator is going to tell you negative pi over 3 because it's going to be less than 90 degrees. That's the only one of those angles that's less than 90 degrees. So your calculator is going to tell you negative pi over 3. And that's the answer we're looking for because it's technically a reference number. All right, finally, inverse sine. So if you went through all of our different trig functions, you'll notice that sine never equals radical 3. So since there's no angle that gives me an exact value of radical 3, this one is not defined. And if there's no angle that gives you that exact value, we're just going to write not defined. Continuing on, I just want us to use a calculator to find these expressions and correct the 5 decimal places. So I'll show you on your calculator where you can find the inverse functions. Remember, your calculator needs to be in radian mode. So I'll show you how to do it on our TI-83. Okay, so the first one they have is inverse cosine. So I'm going to make sure my mode is in radian mode. You'll see it here. You can switch it between degree and radian, but I want it in radian mode. And then I just do second cosine of negative 0.25713, and we get a value of 1.83045. Remember, they want it rounded to 5 decimal places. So since I got the calculator up, I'm just going to go ahead and do the inverse tangent. It's the same deal. It has to be in radian mode. Inverse tangent is just second in the tangent button, and then negative 0.25713. And that gives me that value there. So allowing our calculator to do some work for us, we come up with inverse cosine of this value gives us 1.83085, and the inverse tangent of this is negative 0.25168. Okay, so you can go ahead and try those examples like that. If they're not numbers we know exactly, then your calculator is going to have to do it. And finally, they want us to evaluate, well, actually I have two more just like this. Evaluate this equation by sketching a triangle. So I'm going to sketch a triangle. Since we have a positive sine value, I'm assuming it's in the first quadrant. And sine is opposite over hypotenuse. So if this is my theta, opposite is 3, hypotenuse is 5. And if you do the Pythagorean theorem, you'll find that my missing leg is 4. So the first thing I'm going to do is the sine inverse of 3/5. Well, if I took the inverse sine of 3/5, that's just going to give me theta. We don't know what theta is, but it doesn't matter because we're not looking for theta. We're looking for the cosine. So the inverse sine of 3/5 is theta, and then cosine of theta, cosine is adjacent over hypotenuse, so this just equals 4/5, right, because adjacent over hypotenuse. So we have solved this equation by sketching the triangle and then finding the cosine of theta. One more, just like this. I'm going to go ahead and sketch the triangle. Okay, tangent is opposite over adjacent. So since tangent is 5, we can assume that that's 5 over 1, right? So opposite of my angle is 5. Adjacent then is length 1. And if you go ahead and do the Pythagorean theorem, you're going to get that your hypotenuse is radical 26. So let me do that real quick. Remember, the hypotenuse or Pythagorean theorem is a squared plus b squared equals c squared. Go ahead and plug in for a and b. C is your hypotenuse. And so we can see here we get 26 is c squared. So square root 26 is my hypotenuse. Now I go ahead and solve my equation. The tangent inverse of 5 is, again, cosine of then theta. I don't know what theta is, but I'm not worried because I'm really looking for the cosine. I'm not looking for the angle. So cosine of theta is adjacent over hypotenuse. So the cosine is 1 over square root 26. And if you rationalize that, 26 over radical 26 over radical 26. So it's not cosine of that, it's cosine of theta equals this now. And that gives us radical 26 over 26. Okay, so now you can try the example problems that accompany this PowerPoint. The answers are at the end of the PowerPoint, and there are some practice problems that go along with section 7.4 in the book. You can shoot me some questions on Piazza if you have any while you're going through this.